demystify the entire real number system and give you the tools to classify any number you see, no matter how weird it looks. So let's just dive in. I gotta ask, how well do you really think you know your numbers? I mean, you use them every single day, but could you spot the crucial difference between these two fundamental types in like a split second? Let's do a quick fire round. One about the number 0. Is it rational? And what about the big celebrities like pi or the square root of 2? They all feel pretty different, don't they? Well, stick with me because by the end of this, you'll know the answer to all of these instantly. So to answer all these questions, we just need one fundamental rule. Just one. It's the thing that sorts every single number into one of two buckets. You could almost think of it like a secret code or a secret handshake for numbers. And once you know it, you'll see them all in a whole new light. And here it is. This is the secret handshake. A number is rational if you can write it as a fraction. Simple as that. You know, p over q, where p and q are both integers, and this is super important. The bottom number, q, can't be 0. That's it. That is the one rule that governs everything. Okay, so let's go back to our first mystery number, 0. Can we use our new rule on it? Can we write it as a fraction? Absolutely. You can write it as 0 over 1 or 0 over 2, heck, 0 over a billion. It works every single time. So yep, 0 is officially a member of the Rational Club. And what's so cool about this is that once you know the rule, you realize whole families of numbers get an instant invitation to the club. All those natural counting numbers like 1, 2, 3, they're in. Just pop them over a 1. All the integers, you know, the positives and the negatives, they're in too, because every single one can be written as a fraction. Okay, the fraction rule is great, but what happens when you don't have a fraction? What if you've just got a long, messy decimal staring at you from your calculator screen? Well, it turns out there's a super quick visual test. You can tell if a number is rational or not just by looking at how its decimal behaves. And this really breaks it down perfectly. Rational decimals are, well, they're predictable. They either just stop, like 1/2 becomes 0.5, and that's it, or they get stuck in a loop that repeats forever, like 1/3, giving you 0.333 and on and on. But irrational decimals? Oh, they're a whole different beast. They're like a wild, never-ending guitar solo. They go on forever, but they never repeat. You'll never find a pattern. All right, now I'm going to give you a real pro tip. This is a little secret that's going to save you a ton of time, especially on a test. It's a brilliant shortcut for figuring out if a fraction's decimal is going to stop or repeat, and you don't have to do any division at all. So picture this. You see a fraction, maybe something like 7 over 40. Is the decimal for that going to be nice and clean, or is it going to be one of those messy, repeating disasters? You've got to know the answer fast, right? No time for long division. So what's the trick? Well, the secret is all in a denominator, the bottom number. All you have to do is break it down into its prime factors. Now, here's the magic part. If the only prime factors you find are 2s and 5s, that's it. The decimal will stop. It will terminate. But the second another prime number sneaks in there, like a 3 or a 7 or an 11, bam, you know for a fact that decimal is going to repeat forever. It's that simple. Okay, so we've got the main idea down, right? We're sorting numbers into two big buckets, rational and irrational. But now, let's go a level deeper. We're going to look inside that irrational bucket because there's another layer of classification in there. And honestly, this is the kind of detail that really shows you know your stuff. So it turns out that not all irrational numbers are created equal. You could say they come in two pretty distinct flavors. And understanding this difference, it's like going from just knowing the alphabet to actually being able to write poetry. It's a big step up. So here's the breakdown. The first flavor is algebraic. An irrational number is algebraic if it's the answer, you know, the root of a pretty simple polynomial equation. Like the square root of 2 comes from the equation x squared minus 2 equals 0. But then you've got the transcendental numbers. These guys are the true rebels of the number world. They are not the solution to any simple polynomial equation like that. And that's why numbers like pi and e are so special. They're in a league of their own. All right, let's do a quick check. You know the fundamental fraction rule, you've got the decimal test, you've got the denominator shortcut, and you even know the advanced classification. So I think it's time we put all that new knowledge to the test with one final challenge. Okay, here's a statement you hear all the time, and it kind of makes sense on the surface. The product of two irrational numbers is always irrational, right? I mean, if you take one crazy, never-ending number and multiply it by another one, the answer has to be just as crazy, right?
But is it true? Is that statement always the case? Let's make it simple. True or false? Take a second. What do you think?
You know what? Let's not guess. Let's actually test it out. We know for a fact that the square root of 2 is irrational, and the square root of 8, also irrational. So, what do you think happens when we multiply these two together? Well, check this out. The square root of 2 times the square root of 8 is just the square root of 16. And we all know the square root of 16 is just 4. And what kind of number is 4? Well, it's a whole number. We can write it as 4 over 1, which means it is absolutely 100% a rational number. So that statement is false. That one little example completely busts the myth. The product of two irrationals is not always irrational. So, we've just debunked a pretty common myth, but I want to leave you with one last question to think about. What happens if you add a rational number and an irrational number? Does the wild, chaotic nature of the irrational number always take over? What do you think happens then?